friends, I'm back again with a new video. This video is in regards to the reverse engineering tutorial that I'm working on, and this is the second part of the series. In this series, my concentration is going to be on teaching to look and understand how the conditional statements are written within a program, as well as how to differentiate between a switch and an if-else loop. So let's get started. If you have gone through my earlier tutorial, it explains in general about the basic aspects of x86 to some extent, the prologue, epilogue aspect, how in a way the calling conventions are. Just to mention, I want to clarify a few things with respect to calling convention. So usually the calling convention that's followed for C programs is C declared, where the caller pushes all the arguments from right to left, basically pushing arguments down one after another. So the rightmost argument is pushed first, and then the middle argument and so on. The first argument is on the top, so that way when the function that is called, it can retrieve the very first argument essentially. So that's a C declared function where the arguments are pushed right to left, and at the end, basically the caller is responsible for clearing up the stack. So that is C declared. In standard call, however, it's the same way of passing the arguments, that is, passing the arguments right to left on the stack, but the callee is responsible for clearing the stack. And finally, a fast call convention, in this case, the first argument is passed in the ECX register, and the next two values, or more values, are passed in the stack, and the callee is again responsible for cleaning up the stack. So those are the three calling conventions that I kind of missed on covering up in the last section, so I'm just quickly going over them. So getting back to this program, as I had said, my intention over here is to define how conditional jumps work. Usually conditional jumps represent if-else statement in a regular C source code, and how to differentiate between conditional statements as well as the switch statements. So let's jump into the main. So this is the main function of the executable that I've written. As we have seen, these are the prologue instructions. The main instruction that starts usually is at this specific address. You can look that we are basically pushing values, as we had discussed in the earlier case, and we are adjusting the ESP. So the ESP is arranged over here, and then EBP. So ESP plus 8 would mean that you're pushing something over here, then here, and then finally over here. So basically you're pushing ESP plus 8 with this value, then pushing ESP plus 4 with 1622, and finally pushing 1623. So it seems like this function is, at least based on so much understanding, the push instructions, which are arranged as move instructions. It seems like this function max is taking key arguments. A lot of times the names of the functions would indicate what that function is supposed to do. So based on the name, you can probably guess that this function is supposed to return the max of the 3 elements. So now let's jump into the function and figure out what exactly is happening. So as I said, when you jump into the function, the first thing you will see is the prologue, which is what you see in these 3 instructions. If you remember, we had discussed about how arguments are accessed. So if you remember that aspect, here is your EBP, here is your ESP jumping into that max function, here is the return value, which is the IP, and here are the 3 arguments and the way they are arranged. So if you think about it, what it's trying to do is move EX on this line from EBP plus 8 and compare that value with EBP plus 12. So EBP plus 8 is going to be this. Let's call it A, and let's call this value B, which is the way the arguments have been passed, and this value is C. So if you look at it, what it's trying to do is compare basically A with B, and then use a jump. So you will always see that there's a compare statement and there will be a jump statement. The jump usually says JLE. In this case, that means jump if less than equal to. If it's JGE, that means it would mean jump, greater than or equal to. Basically, in this case, there's no register mentioned, so keep in mind that it's basically using the register in the earlier instruction. So the EAX register is the one that it's comparing. So when a compare is done between EAX, which is in this case A compared with B, what it's trying to see is if A is less than or equal to B, then jump over here, otherwise jump here. So what that usually in x86, when the compilers always convert the values in the reverse order. So based on our interaction, we can see that the main function will be called like this. This is so far what we have identified about main. Let's go to the max function now and try to decipher. So it takes three integers as what we know. Let's call them int e, int b, and int c. So it seems like it's int a. This is int b, and this is int c. And the very first statement, if we understand from the pseudocode that we are trying to create, it seems like if a is greater than b. The reason I'm saying it's greater than b is usually compilers reverse the jump statements. So if the actual statement is saying that if a is greater than b, the compare statement would be like jump if a is less than or equal to b on this side or on that side. So that is a common way, and if you think about it, basically it's the way a compare statement is written that helps you to understand that aspect. But to keep in mind and ease this, that usually everything that you see in terms of jump conditionals is usually the reverse of what the actual statement is. So it compares, let's assume that it finds that a is less than b, but at that point of time it again goes to this specific statement. Again, it seems like we are moving the same values again back into ex. So in this case, however, you're moving eb b plus 12, which means that it's moving ABP plus 12, which is B in this case, and ABP plus 8, which we know. I'm going to close this. Which we know is A. It's comparing again if. So let's assume that if A is less than B, then it's trying to compare is B greater than A. And I'll explain to you why the statement looks so weird, because obviously that should have been clarified. But let's carry on with the flow. So now it's saying that if jump if less than A, so if B is less than A, if you think about EAX now has B, and it's comparing EAX with EB plus 8, which is A. So if B is less than equal to A, then jump over here, which would mean that it's basically saying that C is the element, because you can see that it's moving EPP plus 16 right, yep. So it's moving EPP plus 16 into EAX and substituting that in ESP plus 4, and then pushing this specific value over here. We can see it's pushing printf. So basically it's moving EAX into ESP plus 4, which will be the stack, and closer to that specific value, and moving this specific thing. So basically it's saying that if B is also less than A, then you're going to go and say that C is the largest element. However, if B is greater than A, then it basically comes over here and compares B with 16, which in this case, if you think about it, it's comparing with C at that point of time. So your C is EBP plus 16, and it's comparing against that and saying if B is greater than A, and then B is greater than C, and B is less than, however, C, then C is the greatest element, and that makes sense. So it seems like it's a double AND statement for if and else if clause. Similarly, let's get back over here. So in the first part, we were looking at this aspect of it where we were comparing A against B and doing a jump in. So let's say if A is greater than B in this case, then it comes over here. And it's taking EBP plus 8 and EBP plus 16 and doing the same sort of comparison. So the statement looks something like this. If A is greater than B and A is greater than C, and the reason I'm putting A is greater than C is you can look that EX has EBP plus 8 and it's comparing EX with EBP plus 16, which is comparing A with C, and it's doing basically a jump of if less than equal to. Again, it's going to be reverse, so I'm basically comparing if A is greater than C, and if it is greater than C, in that case, 8 plus 8, so jump if less than C. Yeah, it basically means that at that point of time, we are basically moving A into EX, and that value is moved into the stack, and then the next value, this is pushed again, and printf is called, which prints the value that A is the max element. Similarly, as we had seen, so it seems like we are basically doing two things over here. As we are seeing, it seems like I'm also doing this. So based on that, it's printing max element %d/n into n. And so that makes sense. Now we are doing the same thing, and we are basically comparing if b is greater than c. This is based on the aspect that we have looked over here, that it's comparing ABB plus 12. If b is greater than a, then it comes over here and checks if b, which is EBB plus 12, and c is EBB plus 16, compares them and tries to jump if less than equal to. So that means if b is greater than, in this case, if you think about it, it's comparing if b is less than equal to c, then jump over here. However, if b is greater than c, it's coming over here and saying max element %d/n. It's moving ABB plus 12, moving that into ESP, and the same thing that we can see. And so it's gonna be something like if statement, or it could be an else if statement in this case. So you might not be able to get the exact code, but it's pretty much same, same that it's basically doing a comparison this way. And if you look at the final statement, it seems like it always defaults to this specific value if b is greater than a. So the max element is going to be something like this. If none of these two values are true, then it's doing basically an else. So if you think about it, when it compares with b is greater than a and finds that as b is not greater than a, then it will come over here, which is what your statement is over here. So if a greater than b fails, however b greater than a also fails, which cannot technically happen, but if you think about it, what I'm trying to do is basically compare b greater than c. So this is a redundant statement, and this would basically never be these two statements. Technically, if a is greater than b and b is greater than a, only one of them would be true. So if you think about it, it's never gonna go from here to here to here directly. It's always gonna go from here to here, and then it's gonna compare against this, and if that also fails, then it's gonna compare over here. The way the compiler has arranged the statement, it looks like that we are doing falsified state corrections. However, if you think about it, basically I'm just comparing a with b and a with c, and if that's greater, then a is greater. Otherwise, you're doing b is greater than a and b is greater than c, then b is greater. Otherwise, we basically just say that, yeah, you know what, in this case, that means c is greater. And so the compiler arranges certain types of statements in a way that are hard to decipher and makes you feel that you're doing something wrong. Basically, this control flow would never occur where you are going this way, where b is greater than a, and then again you're going to this part where b is greater than a, but it's basically doing a comparison between b and a, and one of them is greater, so it will come over here. Alright, so this is basically how an if statement looks like, and this would be the epilogue. In this case, it's doing a leave and return. So this is how your max statement looks like. Alright, so now we understand what max does. It's basically doing a comparison of 3 elements. Now let's get back to the next element. It seems like once we come out of max, the next thing it does is moves 6 into ESP, and then call try_switch. So again, this is basically a way of showing how switch statements look like. To understand the difference, if it is an if or multiple if else, or multiple if else if statements, or it's a switch statement, there is a slight difference of identifying how that works. So let's go. So basically, it seems like there's only one argument that the specific switch statement or try_switch function takes. So now let's go back to our main function and then put this like this. And so now the next statement is try_switch. Let's jump to that. So this is the prologue as discussed. The first thing that the statement does is compares the EBV plus 8. So similarly, as we had seen the stack, in this case the EBV plus 8 in this case is going to be 6. This is the first argument and the only argument to this function. It compares against 7. It says this is JA, which means jump if above. So it says if this is above, so the value that is above, then jump straight away over here, which indicates not in switch, which means this is a default statement, it seems like, for that specific. So all the values, it seems, have to be less than 7. Alright, so we understand that part. So let's go. So try_switch takes one int, and the first statement that it does is if the int a received is greater than 7. Now think about it. This can be represented as this if statement, which is how it looks like. However, if that's not the case, that means the value is less than 7, it goes over here. And if you look over here, this is what indicates that this is for a switch statement. It's moving the value, EBP plus 8 into EX. Shifting left means basically multiplying by multiplying the EAX with 2 raised to whatever would be the number over here. So if it was 1, it would be 2 raised to 1, which would be 2. In this case, since it is 2 raised to 2, it's multiplying the specific value by 4. Once it multiplies the specific value by 4, that means, let's say in this case we have power 6, that would be 24. It's basically adding the EAX with offset this, which would result into, so if you think about it, if you go to the specific statement, it looks like it is a table, and this table is indicated by different addresses. Since we are identifying 24 is the multiplication of EAX, since we already know that 6 is passed and 6 into 4 is going to give us 24. Every address, so this is a table, each value in that table is addressed by a 4-byte offset. So you have to think about adding this with plus 24, which would bring you basically to this specific, so 4 bytes, 12 bytes, 16 bytes, 20 bytes, and 24 bytes. So if you were, so if this was the, so this is the original, so this would be 0, this would be 4, this would be 8, this would be 12, this would, I'm sorry, this would be 4, this would be 8, this would be 12, this would be 16, this would be 20, and this would be your 24. So this is a 24th offset in that specific table, and that's what you're doing, is basically adding that and then jumping. So if you go back, you add that offset, move the value, which would be in this case, if you think about it, the value is going to be 401768 by adding with 24. Let's do that this time. So when it goes to that specific address, it finds A4 would contain basically B8, and B8 would basically contain the specific value. So just to make this clarified, again, we multiply that specific value by 4 because of the 2 raised to 2 aspect, and then basically calculate the 4-byte offsets. Every address is 4 bytes, so this is 0 to 4, 4 to 8, 8 to 12, 12 to 16, 16 to 20, and 20 to 24. So the 24th offset is what we are interested in, and that contains this specific value. And so if we jump over here, I guess I was wrong about it. So this is the value of the 0th offset, this is the value in the 4th offset, so it's going to be 4. This is going to be 8. This is going to be 12. This is 16, 20, and 24. So this is what we'll be doing. And the reason I say that is because if you look at the value, it seems like it's a simple case statement that's just checking, and jumping this. So basically, if it's receiving an integer, it seems like it's checking if a is greater than 7. If it isn't, then it's basically doing a switch statement. Those set of instructions that you saw over here usually indicate that this is a switch statement. So in this case, as we were saying, this is going to be switch A, and it's basically doing case 1 colon. So if you look at one of the, they all are exactly alike, which indicates that this is specific this statement. It's basically moving offset 1, this value, into the ESP and then calling puts. So puts is usually a statement for printf when only one argument is passed. So it's basically doing something like this, closing with break, and then similarly then it keeps on going on for case 2 to case 7, and then there's a default case that we saw, which will have the printf not in switch. That is based on the aspect. So if you look at it, all of these statements look alike. This also indicates that this is a switch statement, and the way the table offset alignment has been made by multiplying and shift lefting. This is common with respect to GCC compilers. You can identify that this is a code pattern for switch statements. And so the default state is not in switch, and then there's a break. And that's how this function looks like from our perspective. Just to make sure, let's check again. So it's not in switch, and finally it comes over here and leaves and returns. So that means it does an epilogue and then returns back. And so let's go back to it. And finally, as we saw, it seems like we're moving against 0 and then leaving and returning. So usually if it's int main and if 0 is added, that means we are doing something like this, and that should look as these three functions. Looks like we have deciphered how conditional jump statements and switch statements look like in this specific video. In the next video, my goal would be to show how loops work and how they look like, and some other aspects of x86 operating system, including the pointers and stuff like that. So thanks again, everyone. Have a good one.